In this video, we're going to be focusing on factoring where there is a C value and there's an A value of 1 or some obvious factors, usually things less than 5. If you're looking for solving by factoring where there's no C value or square roots, then you need to look at the other video. So let's get started. So when we're talking about solving by factoring, I prefer to use the box method. There are other methods out there, but I find that this is the most accurate and the most easy to grasp for students who are struggling, particularly with this concept. So the first thing that you need to make sure you understand is where the letters are coming from. So the general form, when we're talking about factoring, is the standard form, where it's ax squared plus bx plus c. If you don't have all three terms, then you might have misused the flowchart and should have ended up in one of the other places. So when we're using the box method, you put the things from the equation inside of the box, and then you find out what's going on the outside edges. What goes on the outside edges will make your factors. So the way that it always starts is the x squared piece goes in the upper left, and the constant term, the 16, goes in the bottom right. And basically what we're looking for is how do we break up this 10 into these empty boxes in order to make this into a box that factors out to these outside edges in a way that makes sense. Now the way to figure those out is what my teacher always called the diamond method. And how we set up the diamond method is you take your A value times your C value and make that the top. So in this case, our A value is 1, our C value is 16, so 1 times 16 is 16. Then our B value goes on the bottom. And what we're looking for is two numbers that are going to multiply to make 16 and at the same time add to make 10. Now if you're having trouble figuring out what those numbers might be in your head, I like to make a list of the factors. That seems to be the easiest way for me to keep track of this. So I look at the factors of 16 and make a list of the pairs. So 1 times 16, 2 times 8, and 4 times 4 are the factors of 16. Once I've got my list, I'm looking for whatever pair here would add to make 10. In this case, 2 and 8. So those are my two boxes, or what's going to go in my two empty boxes here. Now that I've got the boxes filled in, I need to figure out what would go on the outside edges to multiply in to make these spaces. So what is the greatest common factor of these two pieces? That's where I always start. So the greatest common factor would be x. I use this spot as kind of my anchor, and then I work my way around to figure out what's going to go in the other three empty places. So what times x makes our x squared? That would have to be x. And then what times our x makes the 2x down here? And that would be 2. Now that I've got this side filled in, I can find out that final remaining spot. So x times what would give us our 8x, and that would have to be 8. And then just to check my math, I always check the 2 and the 8 to make sure that they make this bottom corner box of 16, which they do. So my factors are x plus 2 and x plus 8. Now to solve, it's just whatever makes each parenthesis work out to 0. So in this case, x is negative 2, because negative 2 plus 2 would be 0, and negative 8, because negative 8 plus 8 would be 0. Let's try again with a little bit more challenging of a problem. So the x squared term goes in the upper left, the constant term goes in the bottom right, and then I have to figure out how am I going to split up the x's in order to make 3x between these two empty boxes. So I set up the diamond method. A times c goes in the numerator, so 2 times negative 5 would be negative 10, and the b value goes in the bottom, or 3. So I'm looking for numbers that multiply to make 10 and add to make 3. Again, I always make a list of the factors of the thing I'm trying to multiply to make. You always want to start there. So in this case, the factors of negative 10 would be negative 1 times 10, negative 2 times 5, negative 5 times 2, or negative 10 times 1. And then I need to figure out which pair would add to make 3. It should be this pair right here, negative 2 and 5. Now that I've figured out all the boxes, I need to work my way out and say, I like to start with my anchor, like I said. So what is the greatest common factor of these two pieces? And they're both divisible by 2x. Now that I've got that anchor in place, I work my way down the side. So what times 2x gives us 2x squared? And that would just be x. And then what times 2x gives us our negative 2x, which would be negative 1. Now that the side is filled in, we can find our final piece. So what times x gives us our 5x, and that would just be 5. And just to check to make sure my math is right, negative 1 times 5 does give us the negative 5 that we need down in the bottom right-hand corner. So my two factors are 2x plus 5 and x minus 1. And then I need to solve them to figure out our two solutions. So the second one is a little bit easier because 1 minus 1 would be 0. However, the first one's a little bit more challenging. So if you're ever having trouble figuring out what the number needs to be, if you take that factor and set it equal to 0, you can go through and just solve using old school algebra to get your answer. In this case, negative 5 over 2. One more example. So, upper left would be our squared term. Bottom right is our constant term. Set up the diamond. So a times c is the top and b is the bottom. So 24 and 14. So if you're ever having trouble figuring it out, make a list of the factors of the number we're trying to multiply to make. So 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And I'm looking for the pair that adds to 14, which in this case would be the 2 and the 12. Now we're ready to factor. So the greatest common factor of our anchor piece here would be 2x. And then what times 2x gives us our 4x squared, which would be 2x. And what times 2x makes 2x would be just 1. And then what times 2x gives us 12x, which would be 6. So my two factors are 2x plus 6 and 2x plus 1, which means my solutions would have to be negative 3 and negative 1/2. Again, I'm just solving that off to the side if I can't figure that out in my head. Now, if you were trying to do that problem ahead of me and you got a slightly different answer than I did, that's okay. Because what might have happened is when you got to this point, perhaps you flip-flopped from the way I did this. So maybe, instead of having the 2x and the 12x in the spaces that you did, you had them the other way around. So you had 12x and 2x. So then when you went to factor, you ended up with a 4x here instead, because that's actually the greatest common factor of the 12 and the 4. You might be panicking, thinking, oh my goodness, there's a completely different answer than what we have on the left there. How is this going to work? So if you were to go through and factor, this is what you would have ended up with. And you might be panicking, thinking that is a completely different answer. But if we write it out, we have 4x plus 2, and then x plus 3 if I go through and solve that, I end up with x is -3 and x is -2/4 or -1/2. And I end up with the exact same answers. So even though our factoring looks completely different, our answers are still the same. So that's kind of the nice part about this, is that no matter what, as long as you're following the pattern, even if it looks a little bit different through the middle, we will end up with the same answers in the end. So to sum up kind of a basics of solving by factoring, the quadratic term goes in the upper left, the constant term goes in the bottom right. We use the diamond method to figure out how we're going to split up our b value into the 2 remaining boxes. Once we figure out what goes on the outside edges, that becomes our factors, and then we solve our factors to figure out which one or what makes each of them work out to 0.